Hey guys, my name's Chris Hollywood, and today I'm going to show you a project piece that I've been working on for my third year at Staffordshire University, and that is the procedurally generated dungeon. Now, as the name implies, it procedurally generates a dungeon, so all of the art and all of the tech has been created by me, Chris Hollywood. The only exception is the fire particle you see ahead. That's been taken from the Unreal Engine 4 starter pack, and it's been modified quite a bit to suit my needs. So let's get down to it. So this is the dungeon. We've got a nice little movement system. This entire thing has been inspired by Legend of Grimrock, which is a fantastic pen and paper game that's been moved over to PC, and it's a fantastic game. So here we've got the dungeon here, and we're just going to take a walk around, see the various winding paths and twisting turns that it has. So let's talk about how it procedurally generates it quickly. So it creates a room. At the moment it's just square rooms, although it can be adapted for rectangular rooms. And it doesn't use a grid-based system. A lot of systems use a grid. I do not. This is gone by room, so by using maths it's going to detect where to place the door, and then detect what facing that is, how long the hallway should be, and where to place the next room. And then it detects the bounds of that room so that it doesn't collide with any other room. So let's press forward onto the other room. Let's take a quick look at this room. So here you can see this is the room that we were just in, and now we're going to move to the next room. Well, just a few steps. I'm going to wait for this door to open up, and here's the second room. So it's quite a bit different. Here we go. So for the walls themselves, they are randomly generated, the main part being the bricks. I've created and sculpted a lot of bricks, and using maths, I can place a few bricks, scale them to fit the space, and so each wall is going to be different. So you can see here, here, and here. All the walls are different. The floors and ceilings, I will eventually be adapting to that. At the moment, they're just the same meshes and that they rotate around. But by applying these techniques, you can create a much more procedurally generated dungeon. So let's keep walking around and seeing. So as I said, the inspiration was Legend of Grimrock, which is a fantastic game, and a lot of the art has been inspired by it as well. This project's been a task on both the artistic side as well as the technical side, because I've had to learn how to create modular assets to specify my needs. So with this room opening to see this room, we can take a look at some of the tech behind all of this, I think. So let's escape that, and we're going to go to the level blueprint and show you how it works. There we are. Open level blueprint. So this is the start, when you start the level. This is where the settings are done. If I were to package this and launch it, I could expose these settings, so you could generate your own dungeon just by inputting a few numbers. So we can detect how big the rooms are. They're just squares at the moment, so it's 6 by 6 in this case. How many floor tiles to remove? At the moment it is purely random, and that's the one thing that I'm trying to work on for this. There's a lot of things that I can improve on, but this is the one where I'm not too sure on. It's the pathfinding from door to door, and it's been set up in a way that it's very unlikely for a gap, for there to be basically a giant line through the room and you can't proceed. It's very unlikely, but I have had it happen 1 in 50 times. So we set the amount of rooms. We have a test mode on to detect certain things, such as where doors are spawning and stuff like that, so I know how to debug it correctly, and how many floor tiles a hallway should have min and maximum. And then we just clear all the arrays if we ever want to recreate a dungeon again. And let's go into the generate rooms. And this massive monstrosity. Now, to be clear, it's very archaic and unoptimized. A lot of things are repeated. It's done like that so that I can clearly see what's going on and debug it a lot more accurately. If I were to finish this all completely, then I would put it together and make it much more optimal. But let's get down to it. So we start here. We're going to loop this entire thing by the amount of rooms, and we're going to do a sequence. We're going to set all the variables up and populate arrays, and then we're going to move down into here. We're going to detect if it's the spawn room. If it is, we're not going to remove any rooms. At the moment, I've disabled this functionality because later on, when I work on this project some more, I want to have a spawn room, which is a special room. And by isolating that, I can have a special room and then split off from that. Next, we detect where to place the door. Actually, no, before that, we actually set the ID of each floor tile to 0. And it's a random amount based on the set how many floor tiles to remove here, floor remove. So it's going to set a random amount to ID 0, and ID 0 is nothing. And that will come in handy later. So now we're going to go to the door exits. There's a weighted conversion here of 1 exit, 2 exit, and 3 exits. Obviously you can't have 4 exits because you enter one room, one side. At the moment this has been disabled to 1 because I haven't been able to get it to work with 2 and 3 facings with the current setup I have. However, it is possible. It just requires a bit more of a rework of the code. But let's move on. So here we're just detecting what facing the door is, and using maths we can detect like the position. So for example, the north face, we have to use multiplication and subtraction to get a random ID between 20 and 25 if it were a 5x5 room, because if you were to go from left to right, it'd be the bottom row is 1 to 5, top row is 20 to 25. So we multiply the row width, which is 5, by itself. We take away 1 because with programming it would be 0 to 24 rather than 1 to 25, which would be the amount of IDs or floor tiles there are. We then detect the floor tile and we move on. And then we do the same for the east, south and west with different math functions. Alright, so now that we've detected where the exit is, we can now spawn the floors and walls. So here we're just detecting what floor tiles are set to ID 1, and this just increments the ID checker. I'm going to go to here. If it's a door which is not ID 1, also not ID 0, being empty, we detect the door, mark its location, and save that for later. We then create the floor, and then we move on. Next, we spawn the walls and pillars, which is sequence number 2. Let's go down to here. Here we just make the walls, and we place the wall and then we rotate it. The pivot of the wall is the center of a floor tile, so if we just rotate it by 90 degrees, it's going to snap perfectly to the floor tiles. Now if we go to the wall mesh very quickly, I believe this is it. Yes, here we go. If you see here, this is actually the wall tile. There are no, as you saw in the dungeon, there's pillars. The pillars are separate, and the reason for this is if we were to have pillars attached to the wall, then let's see if we can. Oh no, let's go to. There we go. There we go. So if we were to have 2 walls, imagine the pillar there, then it would be colliding because the pillar's in this gap here, as you can see. So we would have Z fighting, that's not good. By separating out the pillars and detecting where to place the pillars, we can only have 1 pillar spawn, which is optimized, and also no Z fighting. So let's go back to the blueprint. There we go. So it detects which walls it is. It does this by detecting the floor tiles adjacent to the current floor tile. So if there's nothing to its right, then we have to spawn a pillar to the right. But if there's nothing to the top as well, then we have to spawn a pillar to that corresponding. And by doing a bunch of maths, and also detecting adjacent floor tiles, and whether a pillar has spawned or not, we can place all the pillars only once. There we go. And this is just essentially the floor, but for pillars and walls instead. And we also spawn the door here as well. Let's put that there, make it nice and organised. Yeah, and this is where we spawn the door. So once we spawn the door, we then spawn the hallway. So we detect where the door was, Before we detect what the door was, we detect what facing the door was. So let's say it's an east-facing door. Ignore these comments, they're incorrect. So east-facing door, which is ID number 3. So we detect the hallway, and then we detect the location, and then we just start spawning floor tiles between a minimum and maximum amount, as specified in the event graph here. Minimum floor tiles in hallway, maximum floor tiles in hallway. So it generates the floor tiles, and then it generates the walls. I don't want it to generate pillars in this case, and I don't have to do any extra code because the pillar function is down here. So that's quite handy for me. And then by doing a bunch of maths and stuff, we can detect where the entrance of the next room is. Because it generates this entire graph, it generates the room, then it generates the hallway, and then it repeats. So on the next instance, we have to detect where the entrance is for the room to spawn it. So this is where it's done here. And then we save that for the second go around, and then we spawn the entrance door over here. I believe it's here. Somewhere in here we spawn the entrance door, I can't quite remember where. And then it spawns the rest of the room, the pillars, and we keep going and going and going. And yeah, that's the procedural generation blueprint right there. A lot of optimizations to do, it's split up so I can easily debug it, but this is how I've managed to work it out. So let's take a look at the wall blueprint for one final thing. Where are you? Blueprints. I believe it's this one. Yes, here we go. So this is the brick create. All it does is that it detects when it's placed, it just randomly rotates it up or down by 180 degrees. So in theory we have 24 different variations, 12 and then 12 rotated, and then it just generates a brick and then it places it. And then if we go to BP wall, there's a few different variations of brick setups, and it's just going to place them. And then with the bricks randomized, it just places them in this little area here, and then it's generated. So yeah, let's have a quick drink. That's all there is to really show of this project. Let's go back and generate another dungeon. Let's go to simulate instead, so we can actually see it generated. Here we go. Let's go to unlit, and there we go. We can see the dungeon generated. And let's generate it again. And here you can see it's generated again, and it's different each time. And if we go inside the dungeon, oh, let's turn the lighting back on. It looks much prettier. There we go. Oh, whoops. Camera's very fast, but you get the gist. It generates a random room each time, generates the hallway, and it moves on and on and on and so on. And you can get some pretty interesting layouts. You can make the room as big as you want. It can be 20 by 20 if you want. All the math support it. And it can be as small as 4 by 4. Any smaller probably won't work. You can change the amount of gaps to place and how long the hallways are. For future goals of this project, which I'll be developing over time, is to add a 3D layer component. Because this entire thing isn't associated with a grid, I can just simply increase the z-axis by 128, for example, and now we have a second layer. Or minus 128, and now we have a basement. So, stuff like that. I'll also be working on some more procedure generations, such as the ceiling, the floor, add some color variation in the bricks, and other shaders and stuff like that. So, thank you for watching and listening to me bicker about this project. I hope you've enjoyed, and if you have any comments, just leave one to me. If you have any suggestions to improve, then by all means, tell me. I'll be linking my ArtStation profile and the associated portfolio with this video when I put this onto YouTube and Facebook, so you can take a look at all of the assets that I've created there. Again, thanks for listening and watching, and you've been listening to the Legend of Grimrock main theme for the past who knows how long. It's a fantastic game, and it's been inspired by it, this entire project, so again, thanks, and have a good night.